in the classroom.
Morning, everybody. Hello, can you hear me? Can you see the screen?
Yeah.
Yeah. Okay, who's that?
Not Edmondson.
Okay. All right. So let's give the others about a minute or so to join, and then we will begin.
Check it.
No.
You check it. I say.
All right, I'm gonna start 11:05. Time is it now? 11:04. All right, I'm gonna start at 11:05. All right, guys, morning again. It's 11:05 now. So as you know, this session is a revision of the quadratics that we did this week. And so these two questions on the screen are two of the questions we would have covered this week in the class activity. So I just want to work through these two questions and use them to explain the process, what we're doing one more time. And then we're gonna do a couple past paper questions, look at a couple past paper questions to find examples of questions similar to these on past papers. All right, so let's go and do this first question. So now what we have here is we are presented with a quadratic function, and we know it's a quadratic function because of that. They tell us the P, Q, and R are integers, meaning they are positive or negative whole numbers. And we are required to determine the value of each of those, P, Q, and R, and then we are to state the coordinates of C. But when we look at this graph as presented, or the sketch of the graph as presented, all we can identify are the two roots. These are the two roots. And so this is a case where we are working from the roots. We are working from the roots, and we want to go back to the function. We want to go back to the function. And so if we understand how we get the roots from the function, then we can basically reverse that process of going back from the roots back up to the function. So let us do a little quick revision of it. So remember, you really get the roots from the equation. So it is like you would have the function, the quadratic function that is, and from the function we would get the equation, the quadratic equation. And the function will be the whole thing, like for example, y equals ax squared plus bx plus c. In this case, it is p, q, and r, but it doesn't really matter. We're just working with the standard that we normally use in the class. And then the equation now is what you use to find the roots. And the equation is when the expression is equal to 0. So the function gives it the entire graph, but the equation gives it the roots. Let's put this equals 0 here. The equation gives it the roots. From the equation, we're assuming that we'll go through the process of factorizing. So from the equation, we can get the factors. So we can write the equation in a factor form, something similar to this, equals 0. So it's like x minus r1 and x minus r2 equals 0. So we're getting two linear factors. And from those two factors, we would then go down and get the roots. And roots from this factor, what we're saying, if the product of the factors equals 0, then it means that this factor, if this factor equals 0, then the root from that factor would be r1, and root from the second factor in a similar way would be r2. So those will be the two roots. So this is our normal process from the function down to the root. But here now, we basically have to go in the opposite direction. We have to go in the opposite direction. So we're going from the roots now back up to the function. So what it is that we want to basically reverse this process without skipping out any of these steps. We want to include all those steps. All right, there's a critical step between the function and the equation, because the function can either be what we call a smile function or a frown function. This one is clearly a smile function, And in the case of a smile function, the squared term is a positive. The squared term is positive. All right. So when we get to that stage, we have to check. So if we are reversing this process, that I have on the screen, then it means that's a reversing the process. We're starting from the roots this time. So we would have the roots as presented. From the roots, we would want to go and get the factors. Because reversing this process, want to get the factors from the roots. And then from the factors, we're going to go and form the equation. And then from the equation, we can go now and get the function. And that's a process. We're reversing the process. So if you understand this down here, which is what we do normally, then this would be okay. And right inside here is a critical step where we have to check the A value. Between here, we have to check the A. Because remember, you can get a smile function or a frown function from the same equation. I can show it even on the sketch over here. Instead of this being our curve, passing through those two roots, our curve could have been like this instead, passing through the same two roots. All right, and so the two roots would give you about the same equation, but then it's a matter of whether or not the equation relates to the function. All right, and we're going to discuss that as we go. So it could be a frown function or it could be a smile function having the same two roots, and so you have to decide now which you have. In this case is a smile function. And so right here we have that critical step where we basically check.
I think this is the end.
We have to check the A value, because the A value is what determines if it's a smile function or a frown function. So that step we have to check the A value. And I can actually do the calculations right here on the screen. Right here, I can do it right here. Right, so what are the two roots? The two roots are -1/2 and 3. Those are the two roots. So I'm going to write x equals -1/2. And I'm going to write x equals 3. Those are the two roots. So if this is a root, the question is what factor would have given us this as a root? Now remember the question said that P, Q, and R are whole numbers. So you don't want any fraction factors, you want whole number factors. So if we think of reversing how we would get the root from the factor, reversing it. So I can show you. We would multiply up the 2 first and get 2x equals -1. And then we would transpose the 1 and get 2x plus 1 equals 0. And so this is the factor that would have given us that root. So this is something that takes practice. Because remember now, if we had this as a factor initially, 2x plus 1 times, for example, x minus 3 equals 0, then this factor, 2x plus 1, could be equal to 0, and then the x would be equal to -1/2. Right? So it is reversing this that we are now doing. We are going now from the -1/2 back to this factor. Right? So this comes with practice. So we're reversing that process. So I can go and write from this that the factor of this root is actually 2x plus 1 equals 0. And this is the factor. And from this root, we transpose the 3, it will be x minus 3 equals 0. And then now we would put the factors together to form the equation. We're trying to form the equation. So it will be 2x plus 1 times x minus 3 equals 0. This would be the equation already factorized that would have given us these two roots. So we have now formed the equation, but it is already factorized. So from the root, we go to the factors. From the factors now, we put the factors together to form the equation. Then now it's a matter of expanding this equation out into the standard form, because we want the standard form out here. We want to get the standard form in order to identify the P, the Q, and the R. So we're going to expand this now out into the standard form. So how do we expand this? It is the first value times the first value. First, which is 2x squared. That's 2x times 2x. Then the third value in the expansion is the product of the second values, this and this. That's 1 times -3. That's -3. We have equals 0 over here. But then there's a third term. There's a term in the middle, which comes from the far product and the near product. Those two products add together to give me the term in the middle. Because when you expand this in, you'll always end up with 3 terms. All right. So what will happen here now? That this times this negative is -6x, -3. 2x times -3 is -6x. So the far product is -6x. And then the near product is 1 times x, 1x, 1x. And then you add them to get the term that goes in the middle term. The middle term of the factors is the sum of the far product and the near product. -6x plus 1x is actually -5x. So my middle term is -5x. So this now, I've gotten now to the equation in the standard form that if I solved it, I would have gotten these two rules. And I've gotten to that equation by reversing my normal process. Now that I have this equation, the question is this equation related to this function graph that I have? Are they related? What do you use to determine if they are related? Really and truly is the A value. The A value or the squared term. This is the A value, but this is a squared term. All right, so we're really focusing on the A coefficient of the x squared. If the A is positive, it relates to a smile function. And we do have a smile function. So we know that our A value, mute your mic, please. Can you mute your mic, please? Right, so we know that the A has to be positive. The A is greater than 0 because we have a smile function. And what we actually have here is a square term that is positive. The A value is positive. And therefore, this equation matches the function graph that we have. And so there's no need to make any amendment, right? We can say, let's write it out. So based on that, let's write in a different color. Let's write it in black. We can say this equation matches or is related. Let's just write matches the function graph that we have. Because the function graph that we have is a smile function graph where the squared term is to be positive, and we have an equation where the squared term is positive. So the equation and the graph match each other. So based on that, it means then that the function therefore is y equals 2x squared minus 5x minus 3. I will leave off the equals 0. And equals 0 is when you try to find the roots. Or equals 0 is one equation. So this now is a function. That's the graph. Right? Now let me just show you now. If instead, if we were here and we had 2x squared minus 5x minus 3 equals 0. But our graph was this red graph that I'm going to draw now instead. If it was a frown graph and not the black one, then it means that our A would have to be negative, less than 0, because we have a frown graph. In a frown quadratic graph, the squared term is negative, meaning that the A value is negative. And so since in this equation, the A is positive, we would have to, this equation would not match the red graph. So we would have to say, this is not a match. This equation does not match or is not related. You can say it's not related, but we can simplify it and say it does not match the function graph. because this equation relates to a smile function graph because the square term is positive. But I'm saying if we're using the red one instead, that's a frown. We want the square term to be negative. All right. In addition to that, for this one, you can see that the C value is negative. But on this red graph, the C value will be positive. So again, that also shows that we don't have a match. So to get it to match, we would simply multiply by a -1. Multiply the equation by a -1. When you multiply the equation by a -1, it will become -2x squared plus 5x plus 3 equals 0. And then this now would match the frown graph that we have, the red one. And so the red function, the red one I'm talking about now, function would be the function, the red function, the red one that I drew there, would be y equals -2x squared plus 5x plus 3. That would be the red one, if it was the red one that we had. All right? That is what it would be. But it is not the red one, so let me take this off. And let me remove this, but it is not the red one, so we didn't have to do this. So let me erase all of this. I'll show you that for you to see what we would have to do if the graph was a frown graph. All right, but we're having a smile function or a smile equation or an equation relating to a smile function. So now that we know that this is the function for that graph that was given, the smile graph over here. All right? They want us to say the value for P, Q, and R. So if we compare it, y equals px squared plus qx plus r, we see that the coefficient of the x squared right here is the p. So the p equals 2. And then the plus q is -5. The plus q is -5. So plus q is -5, but we don't need to put the plus on plus q, so we can take it off. And then again, the plus r is -3. So we could say the plus r is -3, but again, we don't have to put the plus on the r. All right? So those will be the value for P, Q, and R. That's what the question wanted, right? Determine the value of P, Q, and R. So these are our answers right here. P, Q, and R. These. All right. Then now part 2. Let's go back for the blue. Part 2 wanted us to write the coordinates of the point C. And C right here is clearly the y-axis intercept. And y-axis intercept is where the x value equals 0. So in this function, if you put x value equals 0, then the y value will come out to be -3. But the coordinates of the y-axis intercept is always 0, C anyway. And in this function, the C value, as we normally know it, is -3. So C is a point 0, -3. Anyway you want to look at it, that is at the coordinates of the point C, 0, -3. But okay with that?
Yes, sir.
Yes, sir.
All right, good. So that was a quick revision of that, right? I think the first question I might want to do is one that is similar. They don't set this very often, guys, where they give you the rules and you have to find a function. They don't set it very often. Most times they give you the function and ask you to do stuff with it. Find the roots or find the minimum point. You know, they rarely set a question where they give you the roots and you have to find the function from the roots. It's not a very frequently set task. All right, so let's go on to number 2 now. So number 2 is your simultaneous equation, right? So the question says, find the coordinates of the point of intersection of this line and this curve. So to find the point of intersection, you have to solve the 2 equations simultaneously. Those are the 2 equations. You have to solve them simultaneously. Once you want to find point of intersection of two graphs, a line and a curve, you have to solve the equations simultaneously. Remember, the point where the line and the graph intersect, the x value is the same on the curve and on the line. The y value is the same at the curve and on the line. So at those points of intersection, the coordinates, the x and y coordinates are the same on the line and also on the curve. And that's why we can use an elimination method or a substitution method to do it. But generally speaking, when it's a line and curve we have, substitution most times is the safer way to do it. Substitution, it can be done by elimination, and I'm not telling you that it cannot. Some of them in particular, some of them can be done by elimination. But the majority of them, you want to use a substitution method. And you want most times, 99% of the times, to substitute the line equation into the curve equation for one of the variables to eliminate one of the variables. All right. So let's proceed and I'll explain as I go. All right. So we're solving two equations simultaneously. That's what it comes down to. It comes down to solving the two equations simultaneously. So we have the line first. We have 2x. We have the line. Let me see a line. So we have the line, which is 2x plus y equals 7. And we have a curve, which is x squared minus xy equals 6. Now, this comes under the quadratics topic because we're talking about a situation where you have a line and a curve, and the possibility exists that the line will intersect the curve at 2 points. Now, you can have lines and curves where there is more than 2 points of intersection. Right? That possibility exists. So, for example, you can have a curve like this and a line like this, and there are 3 points of intersection. But for the CSEC syllabus, they will only give you the types. When it's a line and a curve, they will only give you the types where there only exists a possibility for 2 points of intersection. So a curve maybe like this, I have a line going like that, so there are only 2 points of intersection. Or it might be a quadratic curve like that, and a line going like that, and there are only 2 points of intersection. So because there are only 2 points of intersection possible with these two equations, right? When you put the line and the line and curve together to try to find the point where they intersect, because there are 2 points of intersection, possibly. When you put them together, you're going to end up with an equation that can only give you 2 values, 2 roots, 2 solutions. That type of equation is a quadratic equation. So that's why we call this topic simultaneous equations leading to a quadratic equation. Because when you put the line and the curve together, either by substitution or by elimination, you end up with an equation that can give you 2 x values or 2 y values. Why? Because there are possibly 2 points of intersection. So one of the x value will be for here and the other x value will be for there. Or if it is a y value you're finding, same thing. One y value will be for here and the other y value will be for there. But let me just say something to you right now that we're on the call. You can have a situation as well where you have a curve and a line that just touches the curve at a single point only. A possibility exists as well. You can have a line and a curve that where the line touches the curve at a single point only. It doesn't matter, right? When you put the line and curve together at the CSEC level, you are still going to get a quadratic equation. Just that the quadratic equation that you get is going to be one that gives you what we call repeated roots. In other words, the x value, the 2 x values will come out to be the same, right? So an equation like that may look like something like, for example, x squared, like x minus, you might end up with x minus 4, x minus 4, for example, x minus 4 r squared equals 0, and you factorize it. You might end up with something like this. X minus 4 r squared equals 0. If you expand this, let's use 2 for simplicity, 3. All right, so if you expand it, if you expand this now, you will get x squared minus 6x plus 9 equals 0. So I'm saying to you, if your quadratic equation where you put the line and the curve together comes out to be something like this, this equation will give you 2 equal roots. Because 2 factors of this, if you factorize it, will be x minus 3x minus 3 equals 0. So this factor giving you x equals 3, and this factor giving the same x equals 3. So it's like you have the 2 points of intersection at the same place, at the 2 intersecting points coincide, they're at the same place. So you have 2 points of intersection. They call them repeated roots. All right. So you can get equations, or you can get a situation where a line and a curve intersect at one point. All right. And when that happens, you find that you get repeated roots. All right. And so for this, you're gonna get one y value as well. So for example, your y value might come out to be 4, still y equals 4. And so the 1 point that you have is 3, 4. But I'm saying you're still gonna get a quadratic equation, but that quadratic equation is gonna give you repeated roots. Now listen carefully now. When this happens, the question might go on to ask you for the geometric relationship between the line and the curve. The geometric relationship between the line and the curve. So when a line touches, keyword is touches. When a line touches a curve at a single point only, it means that that line is a tangent to the curve. And that is the geometric relationship between them. The line is a tangent to the curve. Tangents touch curves at a single point only. All right, so if you're ever doing a question like this, and you put the line and the curve together, and you solve and you get an equation that produces equal roots, or what we call repeated roots, meaning you're getting one x value and one y value, then it means then that there's only 1 point of contact. There's only 1 point of contact. The line touches the curve at a single point only. And when that happens, that line is called a tangent. Over. That's it. Oh, all right, cool. Yeah, right? When that happens, the line is called a tangent to the curve, and CSEC will give the situation from time to time and ask you for the geometric relationship between that line and that curve. All right, so I want us to remember this one, guys, because we did not do any in the class. We encountered it, but when we start with the past papers and so on, we will encounter these. The majority of them that they give in CSEC are not the tangent situation. The majority of them are not. All right, but let's solve this one now. So we have the line and we have the curve, and we said the safe way to do it is to substitute the line equation into the curve equation, and to do that, we generally write the equation with one of the variables as a subject. So since this variable y stands alone, just y by itself, we can transpose this 2x on the next side, and so our equation would become, if I were to adjust it, our equation would become y equals 7 minus 2x. So that's a line equation now, written with y as a subject. But the point is, at the point of intersection, this y value and this y value is the same. They are equal. The y value on the line and the y value on the curve, they are equal. Now on the line, we are saying that the y value on the line is equal to this. So since the y value on the line is equal to that, we can use that and replace or substitute for the y value in the curve. After all, at the point of intersection, they are equal. And that is how we use a substitution method. So we can say what we are doing. What I've shown in red is what we're going to do. I'm going to say what we are doing. We're going to substitute. This means substitute the line equation into the curve equation. And that's how we're going to eliminate the y from the equations now. So we substitute the line into the curve. And then what you do, you write what this becomes after you make the substitution. So the one that you're substituting into, you write what it becomes. It's gonna become a quadratic equation. So firstly, it becomes x squared. That x squared comes what? Minus this x that was there, And then where the y is, I'm going to replace it with what we have substituted, what the y was on the line, or what we substituted with, which is 7 minus 2x equals 6. This equals 6 comes back here as well. So equals 6. And then we really have a quadratic equation here now. It's just that it is not yet in a standard form. And when you're solving a quadratic equation, you want to put it in a standard form before you try to solve it. Right? Because why? Because the methods and the rules that we use to solve quadratic equations are based on them being in the standard form. The standard form is when you have the x squared term, the x term, and the constant term equals 0. Very important that you put it equals 0. All right, so you want to put the values in that order. All right, we're going to expand out here first, because we still have to follow the BODMAS system. And we must observe that this x out here is actually a negative x, and you're multiplying with a negative x. So this x squared comes back unchanged initially. Then we're going to expand this bracket now, but we're expanding with a negative x, not just with an x. So it's negative x times 7 is negative 7x. Then negative x times negative 2x. The negative times negative becomes a positive. So it becomes a positive 2x squared plus 2x squared. Why is it 2x squared? Because remember, we're multiplying x times x, that becomes the x squared. And this 2 is also being multiplied. And then the minus times minus over what becomes that plus. That's what we end up with there. And then we equal 6 over this side. Then we want to consolidate the values and put the equation in a standard form. Your aim is to put the equation in a standard form. So you're looking for the squared term first. This and this. Those are your squared terms. You're consolidating them. You're putting them together. You're adding them up together. Those add up to 3x squared. 1x squared plus 2x squared equals 3x squared. So our squared terms is 3x squared. So this is 3x squared. They're looking for your x terms next. This is the only x term in the equation. So I'm going to write that down next. Negative 7x. Then this is only constant value in the equation, but we need it on this side of the equation. I want to leave 0 on the right side, remember. So we're going to transpose this negative 6 over here. But remember, when you transpose a 6, a positive 6 becomes a negative 6. So when we transpose it, it's going to become a negative 6. And then we have equals 0. So that becomes the equation. So now it's a matter of solving this equation to find the 2x values where the line and the curve meet. All right? 2x values. So this can be solved now by the quadratic formula, or it can be solved by factorizing. Generally speaking, when you get a line and a curve equation in CSEC to solve it, generally speaking, it can be solved and you get whole number values. All right? Not necessarily whole number values, but exact values, I should say. Exact values. So when you get in exact values, you can factorize. And this one can be factorized. And when I see a prime factor at the end there, either here or over here, this time is just over here, I'm going to use a shortcut method to factorize it. I'm not going to use the AC multiplying and separating the middle term as we did last week. Because the only factors of 3x squared is 3x and x. Right? And then now we know that we're also going to need factors of that minus 6. If we're in terms of the values, the only factors of 6 is 1 and 6 and 2 and 3. So because you don't have a lot of options to factorize it, we can factorize it quickly. So I'm going to write it down like this, as if I'm factorizing it. And the only factors of the 3x, I put them in first. 3x and x are the only factors of the 3x squared. Then it's a matter of placing the factors of the 6 here and there now. All right? But we also have to bear in mind that, remember, the far product and the near product must give it the middle term. Far product and the near product must give it the middle term. Remember also that when the last value is negative, provided the first value is positive, the 2 signs in the bracket will be different. And you give the larger product the sign of the middle term. Which product am I talking about? The far product and the near product. The larger one must give it the middle term. All right? And we can see, I'm going to use some wrong combinations first. So let's say I use 1 and 6 for the factors of 6 and put 1 and 6 first. Let's say I try 1 and 6. The far product right now is 18x and the near product is 1x. The difference between 18x and 1x is 17x. Oh, I know I want the difference. When the last value is negative, it is the difference between the far product and the near product that gives you the middle term. If we're going to use a shortcut method, we have to know these things. All right, and every time we're doing questions going forward and we're factorizing, and the shortcut method can be used, I'm going to use it because I need the students to learn it. All right, so we can factorize some of these things quickly, especially when the n values are prime, are easy numbers to factorize, easy factors. All right, so we can't use the values this way, 1 and 6. What if I were to switch them around? What if I were to switch around the 1 and the 6 and put the 6 here and the 1 here? Then my far product will be 3x and my near product will be 6x. But the difference between 6x and 3x is 3x, and there's a 7x I have in the middle. So it simply means that I cannot use 1 and 6. I cannot use 1 and 6. I have to try them both ways around, and it cannot work. So I cannot use 1 and 6. So it must be 2 and 3 then, because 2 and 3 are the only other factors of 6. But let's say I put them the wrong way around first. Let's say I put the 2 here first and the 3 here, which are the factors of 6. Then my far product would be 6x and my near product would be 3x. The difference between this and this, the far product and the near product, is 3x, but it's a 7x I want. So it means that I cannot use them that way. And so I'm coming to the correct way now, and with practice, you'll be able to look and see the correct way without trying. 3 must go here and the 2 must go here, because the far product now becomes 9x. The near product is 2x. The difference, again, how do I know I want the difference? Because when the last value is negative, it is the difference between the far product and the near product that gives me my middle term, the difference. And the difference between 9x and 2x is 7x. So it means that my values are positioned in the right place. Just a matter of now putting in the signs in the bracket here and there. All right, let's talk about the signs now. So now that I know the values are in the right place, let's talk about the signs. Now, when the last value is negative, provided that the first value is positive, and that's why I tell the students, quadratics are easier to manipulate when the square term is positive, because the rules and the method that we use are easier when the square term is positive. So when the last value is negative, provided that the first value is positive, it means that the 2 signs in the bracket are different. 2 signs in the bracket are different, because it is a product of 2 different signs that will give you a negative. And when the 2 signs in the bracket are different, the larger product, which product am I talking about? I'm talking about the far product and the near product. The larger of the 2 products must carry the sign of the middle term. But remember, you're adding those 2 to get the middle term enough. So since the middle term is negative, you want the larger product, the larger of the 2 products to be negative. Now, the larger one clearly is the 9x out here as compared to the 2x. To make the 9x negative, you have to put the negative in front, the 3, because the sign must go in the bracket, you know. And then you're going to put the plus here. So you see that the actual far product now is negative 9x. See? 3x times minus 3x is negative 9x. And the actual near product inside here is a positive 2x. So you see that the minus 9x and the positive 2x actually add to this middle negative 7x. All right, so that is how you can use a shortcut method. This thing just takes practice, guys. All right, it takes practice. Let me put those back. It takes practice. All right, so that is it. So it means that I factorize it correctly. I factorize it correctly. I just need to practice this method. You can factorize a lot of these quickly without using the method of multiplying the A and the C. All right, so now that I come down to these 2 factors equal 0, remember I'm still just trying to find the 2x values with a line and a curve meeting. I'm just taking time to explain the shortcut factorization. All right, remember it is either this equal 0 or this equal 0. Now think of it. If this one is the one that is equal to 0, and you want to make x a subject, what would I have to do? Would have to transpose the 2 first and put it over here, and then would have to divide by the 3, divide the 3 under it. All right, so just think of it. If we transpose it, negative the 2 over here first, it become a negative 2, and then divide the 3 under it. And so the x we'll be left with from this factor is x equals negative 2 over 3. Then if this is the one now that is equal to 0, and you want to leave x as a subject, then you just transpose this negative 3 over there and become a positive 3. And so this second factor is giving me x equals 3. So I'm not done yet, you know. All I've found so far are the x values where the line and the curve meet. Remember, we're solving the equation of a line and a curve, you know. All right. So we have not done yet. We need to find the y value to go with this one and the y value to go with that. And generally speaking, you substitute those values back into the line equation. Someone asked me in class, why not the curve? The curve can work, you know. Just that sometimes the curve is going to give you 2 values. Sometimes the curve is going to give you 2 values, but the line will always only give you 1 y value for each x value. So that's why it's safer to use a line. And it's always easy to find the values as well. Because if we substitute them in this equation here that has y as a subject, then we're going to get the y values easier. All right, so let's write it. We're going to substitute into the line equation, which we wrote as y equals, what is it again? 7 minus 2x. That's what we wrote the line as up here. 7 minus 2x. Y equals 7 minus 2x. So now, let me erase this. It's a matter of plugging this x value for the x value there to find the y to go with it. And then plug in this x value again in there to find the y that goes with that x value. So let's do them one at a time. So we're going to say at x equals minus 2/3. We're going to substitute this in the line here. That's what we say we're doing. We're substituting the values in line. Y is going to become 7 minus 2 times, I know where this x is, I'm putting 2/3 there, the minus 2/3. So I'm going to put the minus 2/3 in the bracket, minus 2/3, where the x was. And then we just need to work this out. All right. So you can type it in the calculator and get your answer. But then we can work it out. And so, okay, this is 7. This minus 2 times this minus 2 give me a negative 4. When you multiply a fraction by a value, multiplying value, you only multiply the numerator. Because this value out here same as over 1. You multiply the numerator together and the denominator together. So if I remove the 1, then you multiply this value by the numerator only. And so it becomes, the minus times minus becomes a plus actually. It becomes positive 4 over 3. And so now I'm adding a 7 with a 4 over 3. Now when you're adding numbers with a fraction, you want the denominators to be the same. You want the numbers to be related. Because this 7 is same as 7 over 1. You know? So it's almost like you're still adding fractions. You know? But you want the denominators to be the same. You want your fractions to be related. So you want to adjust this 7 to make the denominator become 3 as this one is. How do you do that? You multiply under here by 3 and you multiply up here by 3 as well. So it becomes 21 over 3. Another way to look at it is to say, okay, if I have 7 and I want it to become a number over 3, as a fraction with a 3 on the denominator, then I can multiply by a 3 to make it become 21 and then put it back over 3. Because 21 over 3 is still equal to 7. And then I'm adding back this 4 over 3. Know that the denominator is the same on those two fractions. I can just add the numerator values and put by the common denominator. So this becomes 25 over 3. So that's my y value. And so the point here, let me put it here in red. That 1 point, the question asks us for the point of intersection. The point of intersection. Let me call it point 1. So my point 1, 2 points of intersection. This is the x value, which is minus 2/3. And this is the y value, 25 over 3. That's the first point. I need to find the second point, which is where x equals 3. So again, I'm going to plug the x equals 3 in the line equation to find the y value to go with 3. So let's go back to that. I'm going to say now at x equals 3, the line is telling me that it take the 3 and plug it in the line there to get the y value, I'm going to get 7 minus 2 times 3. This one is easy because 2 times 3 is 6. So like 7 minus 6. 7 minus 6 is 1. And so the second point, let's put it in red, point 2, has this x value, which is 3, and this y value, which is 1. And so these are my 2 points of intersection. This is an answer. That's my second answer. 2 points of intersection of the line and the curve. All right, that's what we were supposed to do, guys. Find the points of intersection. All right, find the points of intersection. Where they meet. They meet at 2 points here and there. Those 2 points. Any questions on that?
No, sir.
Are they okay? All right.
No,
So
sir.
I took my time, go through it carefully to make sure we get one last opportunity to hear the important things. All right, so we're gonna look at a couple past papers now. All right, we're gonna look at a couple past papers just for additional practice that to show you how these appear on exam papers. So the first one I'm gonna look at is let me back this out. Let me back this out. January 2014. There's a question on January 2014. That's the only one I could find. I could find that they give you the rules and they wanted the function. This question right here. This is January 2014, guys. January 2014. Question 9 part B. Alright, let's look at it. So here, what we can see clearly, here, they gave us this function. It says the diagram below shows a sketch of a function. This means that they are only taking values, x values from -2 to 6. It means that the graph starts at -2 here, is -2, and goes up to a y value of 6. That's all it means. It's just how wide the domain. That's called the domain, right? So this is not really very significant, right? But just it means that they're not showing the entire graph. They don't show the entire graph. But the entire graph will continue up here like that and go up here like that. Right? But only showing it for the region between -2, the x is -2 out here, and where x is 6 out here. Alright? That's what they mean. And this is the graph in that region. The smile. So the critical parts of the graph are shown in that region. What are the critical parts of the graph? The roots, the y-axis intercept, and the turning point. So in the region between -2 and 6, all the critical points are there. All right, and we can see the axis of symmetry, the line right down the middle. All right, so that's why they don't need to show anymore, because all the critical points are shown in the region between x equals -2 and 6. If you notice on the function, they use b and they use c. They don't give us the b and the c. In this case, because of x squared, it is clear that the a is equal to 1. Right? It's clear on the function that the a is equal to 1. And again, if you look down here, this is the y-axis intercept. And so it is clear from this that the c value is -5. So those are the things that you can know. You can literally just put in the c value from now. Right? But the question is now, what is the b value? And that is what they tell us to do down here. Determine the value of c and show that the value of b is -4 right here. But here first, let's state the roots of this equation. Very easy in a state, meaning no calculation needed. All right. So let's go from scratch. Let's go from scratch. Let me not jump all over the place. Let's go from scratch and do it in an orderly way. Because I'm trying to explain as we go. So the question says diagram below shows a sketch of a quadratic function, and they give us this, and they give it to us over this range. And I explained here that it's because the critical points are in that range. And we say that the a equals 1, right? Right here, the coefficient of x squared is 1. It says where b and c are constants, right? So it's basically in our standard form, it's just that they didn't bother to put the a, but the a is 1. Right? They put the a, but it is 1. And they gave us the graph, and we can clearly see the two roots And we can also see the y-axis intercept. All right, it says state the roots of the equation. So remember, this is the quadratic equation, you know. And the quadratic equation will always give you the roots. And we can see the roots. That's why I just need to state them. There's no calculation needed. So the roots are from this, x equals -1 and x equals 5. That's what the roots are. So let me write it up over this side of the screen. Let me write it up over here. Let me write it up over here. So from that equation, we can clearly see the roots. So it's like we're working from the roots of the function again. So the roots are x equals -1 and x equals 5. Those are the roots from this equation. So we know the roots. We can see them on the graph. It says now, for the function, determine the value of c. And I said, because in this function, determine the value of c, we can use this point to determine the value of c. We can use that point to determine the value of c, you know. So if we want, we could say that the c equals 5 right now. Right? We can say that the c equals 5 right now. And then we have to determine show that -4. Mute the mic, please. Mute the mic. To show that -4. Hold on a second. Next, right? What I'm gonna do, I'm gonna do the question. I can follow the sequence of questioning, you know, but I can also do the question as if we are finding the equation from the roots, that method that we did in the class. And then we will get the C and the B same time by doing it that way. We'll get the B and the C same time working from these two roots. All right. So these are the roots. Let's do it that way. If these are the two roots, then what are the factors? We need the factors. Going from the roots to the factors. The factors would be x plus 1 equals 0 and x minus 5 equals 0. So these will be the factors actually, right? I'm putting equals 0 because that is how we'll go from here to the root, and that's how we'll go from here to that root. That's why I put the equals 0. And then now to get the equation, we'll go from the factor to the equation. We multiply the factors together. So it will be x plus 1 times x minus 5 equals 0, because normally if you're solving this equation, you would go to this, and then we go to that and that. But we're reversing the process. And then now to get the equation, actually, we just need to expand this out. We just need to expand this out. So the x times x, we're going to get x squared. And the third value is the product of this and this, which is -5. 1 times -5 is -5 equals 0. Remember, the term in the middle now is the sum of the far product and the near product. The far product and the near product. So the far product is -5x, as you can see. X times -5 is -5x. The near product is 1 times x, which is plus 1x. And if you add these two, you're getting the middle term, which is -4x. So the middle term inside here is -4x minus 4x equals 0. That is the equation, you know, guys. You see this equation that they gave us? Is actually that, you know, x squared minus 4x minus 5 equals 0. So therefore, the c is 5 minus 5, which we could also see from the y-axis intercept there. So the c is -5. And they say show that the b is -4, which we got it here. Right? The b is -4. So if you do this work this way that I just did over here, then that would work. This becomes the equation. Right? So that is the equation. It's clear, therefore, that the c equals -5 and the b equals this -4. Understand that?
Yes, sir.
Yes, sir.
All right. Then we'll come to this now that we can actually learn something from. So we have the a and the b. Eh? The question says now, state the coordinates of the minimum point. State the coordinates of the minimum point on the graph. The minimum point now, remember, is right here. Minimum point is this point, you know. We want us to state it. We actually have to work it out. Right? I'm going to show you something today, and I don't want you to forget it after today. All right? You want the xt and the yt really. Points of the minimum point, remember, is xt, yt. We can calculate xt and yt normally because we know the b and the c now. You know. Our function is now, we can write out what the function is. We now know the function. It is y equals x squared minus 4x minus 5. So from that, we know our a, b, and c that we normally use to find xt and yt. A equals 1, b equals -4, and c equals -5. And to find xt and yt, xt first, xt is minus b over 2a. Remember, the t means turning point. So this just simply means x value at the turning point, and this means y value at the turning point. Some teachers will use minus h and k as the coordinates of the turning point. They don't matter. I use xt and yt. All right. So xt is minus b over 2a. So if you calculate it, it is minus, that's this minus. Then the b now is -4. So it becomes minus and -4 over 2 times a, and the a is 1. So it becomes a positive 4 over 2. So it becomes a positive 4 over 2, which works out to be 2. And when your xt value is 2, you can substitute the 2 in the function to find the yt value. I'm going to show you that way to do it, especially when the xt value is a whole number. You can find the y value that way. So we can use yt equals 2 squared, that's what we substitute the 2 here, minus 4 times 2, that's what we substitute the 2 there, minus 5. So this becomes 4 minus 8 minus 5. That's what, -9, plus 4 minus 8 is -4, -4, -5 is -9. -9. That's one way to do it. Let me shift it over and use our formula and see if we get the same thing. So instead of doing it this way, we could have said, or we could use our yt formula, which is 4ac minus b squared. Excuse me, guys. That's wrong from a while ago on the screen. Sorry about that. That's the wrong thing. Alright, so back to the formula. 4ac minus b squared divided by 4a. I'll put in the values. With the 4 times a, the a is 1, times c, the c is -5, minus, and the b is -4 squared, all over 4 times a, where the a is 1. Now this becomes -20. So it should be -20. And this becomes, this minus stays a minus. This 4 squared, -4 squared is 16 all over 4. So this will become -36, because 20 and 16 is 36, and then both of them negative. So it becomes -36 over 4, which you see it works down to -9. Same -9 we have here. So you see that we could have used the yt formula method as well. All right. So those would be the coordinates. So the answer for this would be that the minimum point is the xt is 2 and the yt is -9. So this right here would be the answer. That is the answer. But I want to show you another way to calculate xt in particular when you know the roots. Xt. And let us remember this one now, right? Now xt, remember, right down the middle here, on the x-axis right here, is that xt value. Remember, this is the line of symmetry, you know. The line of symmetry divides the graph into 2 equal halves, such that the distance, for example, over to this root from the axis of symmetry is the same distance over to this root. So it is like this point is the midpoint between here and here. That's what it is. It is like the midpoint right here. So the xt value becomes equal to the average of these two values. So it is -1 plus 5. Average them over 2. 5 minus 1 is 4. So you see it becomes 4 over 2, which is still equal to 2. So we use the axis of symmetry, the nature of the axis of symmetry, that the points are equidistant from it on either side of the graph. Then you can get the xt value that way. So remember, the xt value is also equal to the average of the roots. Average of the roots. Another way to find xt now, I'm telling you. So xt is √1 plus √2 divided by 2. The average of the roots. That's another way to find xt. Think we understand that, guys?
Yes, sir. Yes, sir.
Want to make it stick, write it down. I'm not gonna use this a lot, but you know, you never know. There might just be occasions where it is the most useful way to do it. Because in this example, if I'm doing this example now, if I'm doing this question in an exam, that's what I'm gonna find. I wouldn't bother with this xt formula business and the a and the b. I would just, because I have the two roots. But they ask for them right here now. It will be x equals -1, x equals 5. Those are the two roots. And if down here ask for the minimum point, I know that I need xt. I'm just going to average these two values. I'm going to get a 2 that way. And then after I get 2, I'm going to substitute 2 that I get in this function to get the y value, which is the y value turning point. I wouldn't bother with no xt and yt formula to do it in particular. I would more get the 2 using the average method up here. And then I would plug the 2 as I did here to get the -9 and end up with the point. That's why I would do it in an exam to get the answer quickly. All right, I would bother on the xt, yt this time because I have the two roots and the xt value is always equal to the average of the two roots. But the xt is halfway between the two roots. So it becomes the average of them. All right, so this is the only question I could find that, you know, they give it the two roots and they wanted the function. I couldn't find any more today. I was searching, I couldn't find any more. So I told in the class that they don't set this very often. In fact, I told you that they set it maybe 3 times in 30 years. Not something that they set very often. Most times they give it a function and you have to find the roots. Right? So it is, see, these questions, I call them special questions because they don't come very often. And if you don't do a lot of work, you won't, chances are you won't encounter a question like this, where they give you the roots and you have to find the function. All right, and so to the point where we actually have a method to do it. Because what you want to know, you want to go into the exam room and you want to have the experience of the various ways questions are set, so you don't have to be figuring it out in the exam room. It's always easier when you already know what to do. And that is why it becomes so important for you to practice a lot and practice a wide range of questions from a wide range of sources, so that you know you encounter questions of all nature, and that increases your chance of getting an exam, getting a question on exam that you have seen before, or you have seen one like it before, and you know how to do it. You don't have to spend time figuring it out in the exam, because sometimes if you're in the exam room and you get a question you have never seen one like it before, you know, sometimes you can become a little bit flustered and you waste time and stuff. It's always easier in an exam room when all the questions that you see on an exam paper are similar to the ones that you have done before, and you know exactly what to do, right? And if you practice enough for the CSEC exam, that is exactly what will happen to you. You will go in the exam room, and the questions you see in there will be very similar to what you have done before, and that is how the exam becomes very easy. That is how the exam is easy. So we have to practice a lot, and we have to practice from a wide range of questions, and from a wide. We don't have to go to a wide range of sources. We just need to do all the past papers, all the CSEC past papers. We don't have to go outside of that. Believe me, we do all the CSEC past papers, right, that we can find, right? Don't maybe go all the way back to maybe 2010. Don't, you have to go as far back as 2010 and even further. But at least back to 2010, you must do. At least back to 2010. If you can go even back to 2000, even so, but you know, back to 2010 is good enough. And you're doing the January and the June past papers, all of them. Then when you go in the exam room, then more than likely, the questions you see in there will be very similar to questions that you have done before. And that is how the exam will become easy. All right, enough talking. Let's do some more practice. All right, I'm going to jump to another paper, which is 2018, 90, and 90, because I want to do a simultaneous equation and a past paper. So you see that what we're doing in class actually comes on past papers. All right, so 2018, let me find that one. 2018. Everybody okay with this question that we just did, right? Everybody all right with it? Everybody okay? The one that we just did.
Yes, sir.
All right, good. All right, 2018, 9A and 9B you're looking at, right? See here, so that's how much is equation here, guys. A line and a curve. It's a line and that's a curve. That's how much is equation, right? So I think there's a part A here first. All right, so look at this part A now. This question says, show by calculation that the exact roots of this quadratic equation are these. Now, once I see the square root, this, I know that it must be that they completed the square. They not completed the square. Yeah, complete the square can work, but must be that they use a quadratic formula, which is already in the standard form. So I say they use a quadratic formula, so I wouldn't even hesitate. I would just go about using a quadratic formula to do this. It's a quadratic equation that you're solving, and they're telling us that these are the roots. Right? Yeah, and those are the exact value. They didn't bother to put it in decimals. So there's a quadratic formula we have to use. So in this now, we're going to use the A equals 1, the B equals 2, and the C equals -5. And by the quadratic formula, if the equation is in the form ax squared plus bx plus c equals 0, then the roots are x equals minus b plus or minus, let's write that better, the square root of b squared minus 4ac. Remember, it is everything upon 2a. Everything upon 2a. A lot of persons make the mistake, as I've said before, of putting this part alone over the 2a. It's a common mistake. Let us not make that mistake in this class. All right, so it's a matter of plugging in these values now in this formula to get the roots, right? And so the x is going to be minus, this minus, but the b this time is just a 2. So I'm going to write the 2 plus or minus the square root. Again, the b squared is 2 squared minus 4 times a. The a is 1. A is 1 times c. C is -5. All over 2a. 2 times 1. A is 1. Let's simplify this now. Do a lot of space. So it's -2 plus or minus. This becomes 4. I'm going step by step for you. This becomes 4. See here now. This is -4. Because -4 times 1 is -4. Times -5 becomes a +20. +20. All over 2 times 1 is 2. 2 times 1 is 2. I'm going to continue down here. So x becomes -2 plus or minus. It's again -2 plus or minus the square root of 24. This becomes 24 inside here divided by 2. Now this starting to look similar to this number. You might say, where do I get the 6 from under there? If you put this in your calculator, right? And you have one of those textbook display calculators that I tell you that you must get, it will reduce it for you and show that it is -1 plus or minus √6. But let me show you how to get √6 now. Watch carefully. And I don't know that really and truly this should be on the CSEC, because there's something that we're doing at maths called search, where we're doing a lot of operation with that square root sign. And I don't know that it is actually on the CSEC syllabus. Right? But you could put this in the calculator and get the answer. But let me show you how to get the final thing by breaking it down. Now see this 24 here, it is actually 4 times 6. So I'm going to write this as -2 plus or minus the square root of 4 times 6. That's what the 24 on here is. I put it as 4 times 6 divided by 2. You see the square root of 4 times 6 actually is the same as the square root of 4 times the square root of 6 divided by the 2. Then the square root of the 4 right here is 2. So then it becomes minus 2 plus or minus 2 times the square root of 6. So the square root of the 4 is 2 right there divided by 2. So you see what I get the root 6. And then now you're dividing each of these values by the 2 under here. So when you divide this negative 2 by the 2, you get negative 1 plus or minus. When you divide all of this by the 2, the 2's cancel and will leave us with the root 6. And that is how they get the minus 1 plus or minus root 6 right here. Minus 1 plus or minus root 6. So that will be shown. But I don't know if really and truly this should have been on the paper, because I don't think a lot of persons at this level would have been taught to go from this to that. I don't think so. Because surge is not really a topic on CSEC. But if you put this in a calculator, you will get, it will give you this. Alright, and I think if you work up to here and then say using a calculator, you get this. I think they might give you a marks, considering that, you know, really and truly breaking this up like that, I don't think it's a part of the syllabus in CSEC. It's more admat stuff. Alright, but that is it. But good?
Yes, sir.
Alright. And this again is a special question, guys, because they don't set this very often where they have to write it in that exact form like that. So we have to remember special question because they don't come often. You have to make it rivet in your brain in case you get one like it again. Remember Mr. Shaw break up the 24 into a square number and another number. So you can square root the square part, the square number, square root it. That's how you simplify it. Alright? That's what you have to do. And if I have 24 here and I see my answer of a 6, I must realize that the 24 is 6 times 4 or 4 times 6. And the square root of the 4 part is 2. Alright, so that's your consideration. But anyway, let's move to part B, which is our simultaneous equations. Alright, and in this simultaneous equations, this one is a line, this one is a curve. Remember, curve is the one that usually have products and quotients of x and y. The line is the one that can be written in the form y equals mx plus c. It has a y value by itself and an x value by itself. Maybe a multiple of it, a multiplying constant in front of it. But the curve is usually the one that has products and quotients of x and y. So the values like x squared, y squared, xy as this one does. Sometimes x over y. When you have expressions like those, then you know we're talking about the curves. And the lines now, you always have the x value and the y value isolated from each other. All right, so this one already has y as a subject, and this is xy equals 5. This can be done by elimination too, you know. So what I can do, I can take this, that the line is saying y equal to, and just substitute it for the y right there. Substitute the line to the curve for the y right there. So we can use that method. We can sub the line into the curve or substituting for y. And when we make the substitution, this is going to become x times 2 plus x equals 5. For where this y was, I replace it with 2 plus x, that the line is saying y equal. We expand this now, we're going to get x times 2 is 2x. X times x is x squared. And then this is 5. So on the minus 5, we're going to say this question. Oh, crazy. That's the same equation we're up here, so same equation we ended up with. See that? x plus 2x minus 5. So if I transpose this 5 over this side, I get minus 5 equals 0. So right in the standard form becomes x squared plus 2x minus 5 equals 0. So this is the same equation that they gave in the first part. And you should know because you see it said hence. So the same equation they gave in the first part. So already you know that the roots for this equation, you have them already. This leads to roots x equal minus 1 plus or minus the square root of 6. That's what we got up here. Right? That's what they told us it was. And we worked it out. We actually have to show it, right? That's what we got here. So one of the x values is with the plus and the other one is with the minus. So let's look at it now. So x equals minus 1. That's one of the values. Plus square root of 6. That's why that better. Minus 1 plus the square root of 6. Or the other value is x equals minus 1 minus the square root of 6. And you want to find the y value to go with that. So what do? You're going to substitute it in the line equation up here. This is the line equation. So I'm going to take this x value and bring it and substitute it for the x value there. I'm going to do the same thing with this other x value over here. This x value and take it and substitute for the x value over there to get the y value. Alright, so I'm going to substitute sub into the line, which is y equals 2 plus x. I'm just writing this as y equals 2 plus x. That's the same thing. Y equals 2 plus x. Same thing. I'm going to substitute this first. So at x equal minus 1 plus root 6, the y is 2 plus this, minus 1 plus root 6, which becomes 2 minus 1 is 1 plus root 6. Alright, that's 1 point. So we can put a bracket and put this point, minus 1 plus root 6, comma, 1 plus root 6. That's 1 point. The other point now is here. No, here, sorry, minus minus. The other point now is where x equals minus 1 minus root 6. Put this in the line again for the x right there. So the y in this case will be 2 and then this plus this, which is minus 1 minus root 6, which becomes 1 minus root 6. So the other point is you have this x value and this y value, which is minus 1 minus root 6, comma, 1 minus root 6. That's it. But let me show you how I could have used the elimination method. These are my answers, you know. These are my answers. These are my answers. But let me show you how I could use the elimination method up here now for these two. So if I have these two equations, I could actually use the elimination method. So the elimination method can be used for some of them. Can. So it's 2 plus x equals y. And we also have xy. Shift this over a bit. Let me shift this over. I'll show you how we could have used the elimination method on this one. So again, 2 plus x equals y. I have xy equals 5. So because I know that xy equals 5, if I multiply this by x, I get a xy. So what I'm going to do, I'm going to take this equation, I'm going to multiply it by x. If I multiply it by x, then this becomes 2x. This becomes x squared. And this becomes xy equals xy. But then xy is 5. The other equation said xy is 5. So it means I can take this 5 and replace the xy over here. Alright? And when I do that, so I can say substitute for xy. When I substitute for xy, alright, then I'm substituting for xy that is here, you know, it is equal to 5. Then I will get 2x plus x squared equals, instead of xy now I'm getting this 5. If I transpose it now, I'm going to get x squared, that's this x squared, plus 2x already on the right side, and the left side, sorry. Carry this 5, we get minus 5 equals 0. So you see we end up with this very same equation, guys, right here. Same equation that we have right here. All right, so that's another way we could form that quadratic equation. And the rest of the solution will be the same. So what we did after here, everything down here will be the same after this. But that is it. That is it. Very good with that. Not a special question. Very good.
Yes, sir.
All right.
Yeah.
All right, let's look at 2020, January 2020. There's another question on it. This is another simultaneous equation. And I don't think we're going to see any more of the curves. For the roots given in the curves. Though we're not going to see any more of that right now. They don't say that very often. So I think we're going to see simultaneous equations. We can maybe do another quadratic, one last quadratic to finish off, since it's the last of the quadratics for now. We can maybe just do another quadratics question just for simultaneous equations here. Let's look at this one, guys. Alrighty, let's do this. All right, so we have this pair of simultaneous equation. Solve the pair of simultaneous equation, right? This one clearly is a curve. So the y squared here, so that makes it a curve. This one is a line, an x value and a y value in isolation. Now this one already has x as a subject, right? So no problem. What we can do, just use this and substitute for the x right there. All right, simple as that. But the x value on the line, x value is on the curve is the same at intersection, right? So to solve this, we're going to make the substitution. And in exam paper, on the exam, you know, if you do this because drawing and so on, and you know, show what you're doing, you know, it's also saying to the examiner what you're doing. So no problem in doing that. All right, so we're going to sub the line into the curve for x. Sub the line into the curve. We're subbing for the x. And then you write what this becomes after you do the substitution. So the curve becomes y squared plus 2y plus 11 equals, and then where the x is, we want to put 5 minus 3y. It's a quadratic, you know, guys. It's a quadratic in y. It's a quadratic where the variable is y, not x. But the process of solving it is the same. You have to put it in the standard form first. So when you transpose these things over here and leave 0 on the right side, so this is all a square term in there, which is y squared. Concentrate now. We have 2y over here. When this 3y comes over, it's going to become a plus 3y. So the 2y and the 3y are going to add up to 5y on the left side. So we're going to get plus 5y. Then this is 11. This 5 is going to come over and subtract from the 11. 11 minus 5 is 6. So we're going to get a plus 6 equals 0. All right, and this factorizes nicely because the only factors of y squared is y and y. Y and y. Then here now you want factors of 6 that add to 5. 2 and 3. Signs are the same. They are both positive. Positive, positive. So those are your factors. Those are your factors. Nice and fast, quick and easy. If you check it, the far product is 3y and the near product is 2y. They add to 5y, which is the middle term. All right. So this factor, if this factor equals 0, then it means that the y is equal to negative 2. If this factor equals 0, then that would give y equals negative 3. So we have found the y values already. we just need to substitute to get the x values now. So what better place to substitute them in than in a line that has x as a subject up there. So I'm going to substitute them in this one. So I'm going to sub into x equals, that's the line, sub into the line, x equals 5 minus y. Firstly, this one, at y equals minus 2, the x becomes 5 minus 2, which is 7. So one point of intersection is, you can't put negative 2, 7, guys. No. So even though we calculated the x value second, you still have to put it first in the bracket. As a common mistake when people calculate the y value first. You still have to put them in the correct order. X value, then y value in the bracket. 7, negative 2. That will be the point of intersection line on the curve. 1 point. Other point is where y equals negative 3. Alright. So we're gonna go and say at y equals negative 3. Substituting in this for the y right here, the x is going to be 5 minus negative 3. Again, this minus minus becomes a plus. This works out to be 8. And so the second point, I will put x value first again in the bracket, is 8, negative 3. That is it. I've solved those two equations simultaneously. But all right with that?
Yes,
Very
sir.
good. Sure. Nobody ask a question to them. Mind, you know. Careful. Make sure you understand, you know. All right. Let's continue. I'm taking it that you all understand what we're doing. Well, you should, because we've been practicing in class, so you should all be okay. All right, let's continue. Math equals better. Let's go. So we're coming on. So let's do this. Let's do this as revision. We have not done this in a while. All right? XT, YT and stuff, right? Compute in the square. Let's do this. So this question gives us this function, f of x. It's a quadratic. And they want us to write it in this form. All right. So remember, our method is to use xt and yt. And why do we use that method? Because even though they give us the vertex form, which is what when you compute the square, that's what you get. This is called a vertex form. Even though they give this form with the h and the k far more frequently than any other form, the fact of the matter is that they change it from time to time, and sometimes the students get confused. All right, so we don't want the confusion, and so instead of using this form for the vertex form, we are using a bracket x minus, notice a minus, xt squared plus yt, where xt and yt are the coordinates of the turning point. T means turning point. And we have a formula for calculating xt and yt. Formula for calculating xt and a formula for calculating yt. All right, so our xt formula is minus b over 2a. Where the a and the b come from? They come from the standard form. So in this standard form up here, let's write them out. The a is the number in front of the x squared, or what we call the coefficient of x squared. This is the x squared. The number in front, it is 4. So the a equals 4. The b is the coefficient of the x. This is the x here. The number in front, it is a negative 8. Common mistakes for persons to only see the 8. It's actually a negative 8. You have to see that negative sign. And the constant term is negative 2. Again, a lot of persons will just put 2, but it is actually a negative 2. And that is a C value, is negative 2. Those are the values we're putting inside here. Just to be an A this time. So, ready? This becomes equal to minus B, and the B is negative 8. So I have to put minus negative 8. You can leave it like that, or you can bracket it, don't matter. You can leave it like that. It becomes a plus anyway. And then it's 2 times A, and the A is 4. So it's 2 times 4. This becomes a positive 8 over, and that also is 8. This therefore works out to 1. Now, when my xt becomes a whole number like this, I'm not going to use a formula method for yt. I'm not going to plug that xt value in the function and get my yt value that way. But that's an easier way to get it this time rather than use a formula for yt. So my yt value really becomes f of 1. So because the function is f of x, it's like you put in f of 1 in the function this time. All right, which works out to be 4 times 1 squared. I will put the 1 here, so for the x. So 4 times 1 squared minus 8 times 1. Again, I put the 1 here for this x minus 2. And then you work that out. Now, this is 4 minus 8, which is negative 4, and then negative 2 more makes negative 6. So I have my xt value and my yt value. It means that I'm going to take this and plug it here for the xt, and take this negative 6 and plug it here for the yt to write my vertex form. So it means then that f of x is, I'm basically writing out this now, the a is 4. A is 4. I'm going to write the 4 first into x minus xt is 1. 1 going there. Don't forget the square. And then plus yt is negative 6. If yt is negative 6, then this yt we can put a plus on it. Plus yt is negative 6. So the plus yt that we want here is negative 6. So we're going to put minus 6. And that is it. We have completed the square. What do I write with that? Everybody okay with that?
Yes, sir.
All right, then let's continue. Next part says you have to state the minimum value. Remember, the minimum value is a y value. The lowest y value on the graph is a y value at the turning point. So it's talking about this negative 6. The minimum value is the yt value, which is equal to negative 6. That's the lowest y value on the graph. All right, lowest y value. And you get that lowest value when the x value is 1, when the x value becomes equal to the xt value. So when this becomes a 1, this becomes 0, and the function becomes negative 6. All right, so they ask for the x value when the function is minimum. Let's see if they ask that. Oh, that's right. Determine the axis of symmetry. Axis of symmetry, remember the line through the turning point that is vertical. And to have an equation of a vertical line, which is x equals a number. What number? The xt value. Because after all, it passes through the turning point where the x value is. In this case, 1. 1. Right? So it is x equals 1. That's the equation of the axis of symmetry. X equals 1. Anything else I want us to do? Nope. Done. That finishes that. So this is the answer right there, this one. That's axis of symmetry. Equation of it. Alright, so far so good?
Yes, sir.
Okay then. Let's do another one now. 2021. 2021. Let's see. 2021. Let's look at 2021. More months. All these questions I wanted to read with them, and you know the program already. To go and do these questions all by yourself. I can send the papers in the group, and you go and do the questions over by yourself to practice. More maths equals better maths. You have to practice. So all the questions I'm doing today, I want you to go and redo them. Number 8. Right? This is June 2021. I want to say. June 2021. I'm not happy. We did this last week. So I wrote on the wrong thing. It's June 2021. Let's see. Not that paper, I have the wrong paper there. 2021. This one. That's one I just got my while ago. Not that one I want. January 2021. I want January 2021. Where is it? Right here. All right. So this question actually is a simultaneous equations question right here. A line and a curve. I was showing you how to set it. I was showing you how to set it. You must equation of a line and a curve. That's how to set this one. It says function f and g are defined as this. So this is function f. This is function g. Remember, I know the f of x can be written as y. So it's almost, instead of giving you that, it's almost that they give you y equals 5 minus x. That's what this is. Another function here is y equals x squared minus 2x minus 1. That's a function, but it is linear on a line. It's a function, it is quadratic. I call this function f, the line I call this function g. And the question said the graph of f of x and g of x meet at the point m and n. I mean, that's where they intersect each other. So this will be a graph, a quadratic graph, shaping like this, and then call it f of x on the graph. This will be a line going like this, and they call it g of x on the graph. They meet each other at m and n. So the question says determine the coordinates of m and n. So you have to solve them simultaneously. What's that they call the curve g of x? So the curve is g of x. I put them wrong way around. The curve is g of x. And the line is f of x. Don't matter, we can write them in terms of x and y. Same, I was solving them simultaneously because I want to find the point where they meet. So you see, but a person see this and might get confused, but it's just still a simultaneous equation of a line and a curve. That's all that it is. Alright, so we got this question for you to see. Alright, so we're solving these two simultaneously, and this one is kind of straightforward because you already have y as a subject. So the y at the point of intersection, the y on the line and the y on the curve equal. Y values are the same. So because those two equal, means then that this is equal to this. The y value on the line and the y value on the curve is the same. L means line and C means curve. Right? So at the point of intersection, those two things become equal. Right? So I'm going to say it. I'm going to say at m and n, this thing becomes equal to that thing. X squared minus 2x minus 1 becomes equal to 5 minus x. It's a quadratic equation, guys. Just set it in a basic form. You have to transpose it over into a standard form. So to transpose these over this side and make it equal 0. So this is all x squared term in it. So it stays x squared. And this minus x comes over and becomes plus x under that. So minus 2x plus x becomes minus 1x, or else minus x. So I'm going to get minus x of that. And then this 5 comes over and becomes a negative 5, and this is going to give me negative 6. So I'm just going to minus 6 equals 0. This is a factorized. Why? Because the only factors of x squared is x and x. You want factors of 6 where the difference is 1. 2 and 3 that. 2 and 3. This said the two signs in the bracket are different with the larger product, the negative sign. The far product is 3x, the near product is 2x. Far product is greater, so you make it negative like the middle term. And this one is positive, equals 0. So then this factor giving me x equals minus 2, and this factor giving us x equals 3. So the small amount of space that I give it to work, solve it, so actually you can't be writing too much. Otherwise, you're not going to finish, right? So it's kind of easy now to find the y value because we're just going to substitute the negative 2 in the line right here for this one. So I'm just going to simplify it and say, and for this one, I'm going to say, and y equals, and if I put the negative 2 here, I'm going to get 5 minus negative 2 will become 7. I'm going to write the 7. I'm going to plug in this one, this 3, inside here again. I'm going to get 5 minus 3. Right? So the y is going to become 2. I'll plug the 3 inside here. I'm going to get 5 minus 3, which is 2. So my 2 points, m and n, I can give any other point to any letter. Right? So I'm going to make m be the one with a small x value. So I'm going to write m is the point negative 2, 7, these coordinates, and n is 3, 2. 3, 2. Those are my answers, m and n. So you see, guys, sometimes I can give it a simultaneous equation, but they make it look like some functions, but it's just almost like they're hiding the simultaneous equations in how they present this question. But it don't matter, it's still simultaneous equations. All right, guys, very good with that.
Yes, sir.
All right. Now, what time is it now? It's now, all right, so about 15 minutes left to complete 2 hours, right? So a quick revision that we did today. But there's just one thing that I want us to do, show you the importance of being able to expand the perfect square because of what happened this week in class. It really hurt my heart what happened with the perfect square in class this week. I'm telling you. So I'm going to bring up a question to show you something. All right. January 2017. I'll show you something. So it's not just in simultaneous equations that you have to apply some of these things. You have to apply it in other questions, and that's why you have to learn these core basic things because you have to apply them in several topics. Any random place, you might get a question that pop up where you have to apply it. All right, so let's look at this. Forget what number. Let me see if I can find it. It's supposed to be here somewhere. There's another quadratics. With the curve, and you have to get the minimum point and stuff. That's not what I want. Did I write down the right number for it? Wow. Here it is, right here. Look at this question. It's like a reverse competing square. This, you know, look at it. Question says, given that this thing is equal to this thing, work out the values for A and B. It's like a reverse competing square. So this now the squares are already competed. You know the values in there. And I want to find the A and the B. Alright? So how you think you would approach a question like this? Anybody want to tell me how to approach a question? Very simple. How would you approach? Somebody tell me. Somebody unmute the mic and tell me how you approach a question like this to find the A and the B. Given that this thing equals that, how would you find the A and the B? Anybody want to tell me? Nobody wants to tell me. So the easy way to find the A and the B, guys, is really to expand back this out and bring it back to the standard form and then compare the values. Compare the coefficients of the x and the constant term. That's all I have to do. We have to be able to expand this perfect square the right way. That's all I know. So if you say you're going to expand this perfect square the wrong way and go and write x squared plus 4 for expansion of this, which is what a lot of people would do, you're not even going to get an x term. You're going to put minus 3 next. right? And it will become x squared minus 1. I might want to say the a equals 0 and the b equals minus 1 because you don't see an x term in it. It is wrong because you'd have expanded this perfect square the wrong way. All right. So to do this question, I'm going to expand out this side so that I can compare it with that side. That's what I'm going to do. That's the approach I'm using. That's not the only way to do it, but I think that's the easiest way to do it. So I have to expand this perfect square the right way. All right. So remember, when we expand a perfect square, the first term squared. And what people forget is twice the product of the two. The middle term is twice the product of the two. Let me write this better. The middle term is twice the product of the two. How the twice product of the two? You multiply these two things and double what you get. When I multiply x and positive 2, I get positive 2x. And then I double it to positive 4x. So my middle term is positive 4x. Then my third term is this value squared. Positive 2 squared giving me a positive 4. This is just the expansion of the bracketed term, 3 terms in it. I get, not 2 terms, 3 terms. Then I need to now subtract this 3 back over here. Minus 3. I don't need the brackets. I'm going to remove them. I don't need them. Right? But all I know is that this is expansion of the perfect square, and I'm going to subtract the 3. Consolidate the values now. This is x squared. This becomes plus 4x. Then this 4 minus 3 is 1. Then you can clearly see now that the a is 4 and the b is the 1. If you compare the values, this x squared is there already, but the number in front of x is 4 and the number in the constant term is 1. So based on that, quite easy. This is this. So the a equals 4 and the b equals 1. That is it. Alright, so you see, you have to be able to, this perfect square won't pop up for you to use it only in simultaneous equation. There are several other topics where the perfect square for you to expand it will pop up. Alright, so you have to, the things that we learn in class and the methods and important things and the core skills, you have to make sure that you practice them and remember them. Alright, you have to make sure. I still have a couple of minutes left to complete 4 hours. So let us do another question. There's another question on this paper. I think we did it last week. Let me see. I don't remember. Another quadratics. Now, wherever you see them, you practice them. More maths equals better maths. So wherever you see them, you practice them. That's how you master these things. Practice them over and over again. So they give us this quadratic graph and they give us the function as well. And let's see what they're asking us, right? And they said they give us from 0 to 6. X is from 0 to 6. I mean, at the starting from an x value of 0 go to a y value of 6. And why they do that? They only need x values in this range because all the critical values fall in that range. The y-axis intercept is there, the 2 roots are there, the minimum point is there. So all the critical things about the quadratic function fall within the range 0 to 6, x value 0 to 6. I don't need to show any other parts of the graph. That's why they focus on that section of it. Alright, that section is enough for you to see all the critical things. It says use the graph to solve this equation. See, question says use the graph, So they don't want you to solve this using factorizing and stuff. Say use the graph. Right? So if I'm in the exam and I want to show that I use the graph, I'm gonna code like this and say this. I'm gonna say this give the roots. I'm gonna say the roots. x equals 2, that's right here, x equals 4 at that point. Done. And then I'm going to mark on the graph to show that I use the graph. I'm going to say something like roots, root, root. So because I use the word roots down here, it's telling, I'm saying to the examiner, the solution of this are the roots, and these are the roots. 2 and 4, x equals 2, x equals 4. All right. That is that. Next part says write down the coordinates of the minimum point in the form xy. You can see the minimum point right here. Bam, it's clearly right there. So the x value there is 3, and the y value there is -1. Look at the scale. This is 0, this is -2. So right here is -1. So this point is 3 is the x value, and -1 is the y value. Easy like that. That's the minimum point. So remember, no, this is xt now. This is xt, and this is yt. So you know xt and yt as well. But good with that. But okay. But okay with that.
Yes, sir.
Yes, sir.
That's what they want us to do. Watch this now. Watch this now. They say write this in this form where AH and K are constant. Now look here. I do have to work this out from scratch again, you know. They give me 3 marks, you know. I'm gonna say to the examiner right here to show that I'm using this. I'm gonna say this. I'm gonna write xt yt in front of it. I'm gonna write xt yt equals that. So I'm basically saying xt is 3, yt is -1. What is now? Down here, instead of using this format, I'm gonna go like this and say, all right, I'm gonna use a into x minus xt squared plus yt. That's the method I'm using. I do have to calculate them again. The a is 1, so I'm gonna write 1 bracket x minus xt is 3. I have it on the graph. I do have to calculate it again. Squared plus yt. Yt is -1. I'm gonna write -1. I'm done. See there? This is the answer. This is it. I've written it in that format. But let's say you never know that, and you want to calculate. There's a proof to you're gonna get the same thing. But it don't make any sense. You have it already and then calculate it again. It don't make any sense. You have it already. You see it on the graph. Why calculate something? Remember, I know you calculate stuff in order to put it on the graph. So if it's already on the graph, why you need to calculate it again? You don't need to calculate it again. But let's say you never know. You want to calculate xt. So you're going to write this in the form. You're going to do it like how we do it in class. That's where the understanding of what we're doing comes into play. Right? So we're going to use a into x minus xt squared plus yt. Let's say you don't pick it up that it's already on the graph. So you're going to go through the process again. Then the xt would be minus b over 2a, which would be minus, the b is -6 right there. So you're going to put minus a -6 over 2 times a. The a is 1. 1 equals, this -6 becomes a +6 over 2 times 1 is 3. 2 times 1 is 2, sorry. 6 divided by 2 is 3. Same 3 that we got on the graph already. Why calculate it over again? Yt now. Yt is 4ac minus b squared over 4a. Right? Or we can take the 3 and plug it in the function there, so. And there, so. That's another way to calculate yt by plugging the values in the function. Let's say we're using the formula. Using the formula, it will be 4 times a, the a is 1 times c, the c is 8, minus b squared, the b is -6 squared, divided by 4 times a, the a is 1. So this would work out to be 4 8 what? 4 8 is 32, minus, this becomes 36, divided by, this is 4. 32 minus 36 is -4. over 4. Negative 4 over 4 is negative 1. See? It is to a negative 1, negative 1. But you have it already from the point. It is negative 1. So why calculate something that you already have? Don't make any sense. But understand that? Remember another way to calculate YT if you want it was to plug the X value in there. So if you work it out that way, just to show you, what's the R, YT would be equal to the 3 squared. We plug the 3 inside here for the X squared. Get 3 squared minus 6 times 3. We plug the 3 inside here, so for the X plus 8. Now this is 9 minus 6 3 is 18 plus 8. Now 9 minus 18 is negative 9. Negative 9 plus 8 gives you the same negative 1. But none of this calculation was necessary. I'm in the exam, I'm going to do it this way in red because I already have my XT and my YT from this line. So I don't have to calculate them again. I have them already. All right, this part of it is something different. It says draw the graph of the line. I'm not going to do that part until we do coordinate geometry. So we do that some other time. And then I wanted to solve that. So we'll do that part some other time. We'll do the topic of coordinate geometry. But everybody understand what I was saying with this question? See where I'm going? So you have the information already from the graph. So you don't have to calculate it again. But to go with that?
Yes, sir.
All right. All right. Now 1 o'clock. We're going for just about 2 hours. I think we started about nearly 10 hours. So that's a 2-hour revision. We're going on to a new topic, guys. I think the topic of tomorrow's functions. I don't know. I see one or the other. All right. So I see you all tomorrow in class early. I'm going to start at 11 a.m. sharp. So class early. We're going on to a new topic class tomorrow. All right. So the next time we see quadratics, it's going to be the revision. There's still one thing on quadratics that we need to do, which is qualities, quadratic inequalities. But I want us to cover the quadratic inequality topic first, and then we are going to then I'll deal with the quadratic inequality after that. I didn't want to get into the quadratic inequality without dealing with the inequality topic itself first. All right, so and they don't really set a lot of quadratic inequality, just for you to read quality information off the graph of quadratic function.
Is it working? There we can't hear.
Can't hear me?
Not really.
Oh, you can't hear me? The whole class, you couldn't hear me?
I could hear you.
Oh, friend me. Oh, just now you can't hear me. Just now. You been hearing me the whole class?
Yes, sir.
Yes, sir.
No, say just now.
Or just now I drop off just now?
Yes, sir.
Okay. Oh, I was wondering if I do the whole class, they couldn't hear me and nobody said anything. Frightened me. All right. So what I was saying is that we have one thing left to do in quadratics, which is quadratics inequalities. But at this stage, because we have not done the topic of inequalities, I don't want to introduce the quadratic inequality yet. So when we do the topic of inequalities and also the linear programming, I think we'll appreciate the quadratic inequalities a lot better at that stage. So I won't bother to introduce the quadratic inequalities yet. All right, so we'll deal with that later on. Furthermore, the questions that come on quadratic inequalities now is basically reading off some inequalities from the graph. I don't think they're giving a quadratic inequality to solve because that is more a topic for add maths now. It used to be a topic for CSEC maths in the past, but now it's more a topic for add maths. But you still should be able to read quadratic information off the quadratic graph. all right, or inequality information from the quadratic graph. So we deal with that after we do the topic of inequalities. Okay, so that is it for today, guys. As I was saying, see you tomorrow in class. Make sure you come early. If it's Monday, come early, same way. We're starting off with a new topic right at the get-go. So from the minute the class start, we will be on the new topic, and information, critical information will be shared from the get-go. So you don't want to miss anything. Make sure you come to class early. All right. So see you all then when I send this video. Well, the video is actually a live recording on YouTube. So the reason I do that is because I cannot store all the videos that we do on Zoom, right? Because then I'll be basically be using up the space, and I have a limited capacity that I can use on Zoom. But I don't have a limited capacity on YouTube. So these videos for these revision classes are on YouTube. So I share the link in the group, and I send these papers as well that we did today. As usual, you're expected to redo these questions. All right, redo the questions and use the video to assist, to help you. Pause, rewind, and play. That's how you master these things. You have to practice them. All right, so all the questions that I did today, I want you to redo those questions on your own. All right, guys, so do that for me, please, before tomorrow's class. Okay? All right, I'm gone now. Bye-bye. Bye, everybody.
Bye, sir.
Okay,
Bye, sir.
Okay.
Bye, sir.
Bye-bye, Elizabeth. All right, I'm going to end it now.